Let's take a look at a few more problems using radicals here and see what we can master from this. Notice that when I have a fifth root, I'm automatically looking for things to the exponent of 5 because I know that anything to the fifth power, if I take the fifth root, that anything will come out. If this is to the fifth, then it'll come out as just x to the first when I take the radical there. So clearly I've got that with x to the fifth, and hopefully you see that what's 32? Guys, there are a bunch of 2's in that? I think so. 2 divided into 32 is 16. 2 into 16 is 8. Oh, and I know 8 is 2 cubed, so that gives me 4 and 2 and 2. 1, 2, 3, 4, 5. This is 2 to the fifth. This is really just 2 to the fifth times x to the fifth. So they both come out. The answer to this is 2. Those come out as a 2. And x. These come out as x. There's no radical anymore. When both things come out, there's nothing left under the radical but a 1. Well, fifth root of 1 is 1, so that comes out too, but 2x is my final answer for this. But you've got to see that is 2 to the fifth, and this is x to the fifth. So they both come out. All right. Hope that helps you there. All right. This next one is interesting because we have 4 to the 1/4 and 64 to the 1/4. You must first understand that this is a lot like saying, okay, 4 to the fourth root of 4 and the fourth root of 64. Clearly, there are some 2's involved here. This is 2 squared, or I'll write it as 2 times 2. So I have the fourth root of this times the fourth root of that. Well, a moment ago, I think we learned that 32 is 2 to the fifth. If I double 32, that's just adding another 2. So 32 was 2 to the fifth. If I multiply by another 2, I'd get 2 to the sixth. So if I multiply this by 2, I multiply that by 2. Anyway, 64 is 2 to the sixth. I'm not saying it very quickly there, but here you go. 1, 2, 3, 4, 5, 6. I hope you see that. Okay, let's get rid of that so it's not confusing. Okay, so if I have 2 to the sixth and 2 to the second there, if I put them all together under one big radical, okay, I'm going to get, here's 4 sets, here's 4 2's, oh, and here's 2, and here's 2 more. It's really 2 to the fourth times 2 to the fourth. Okay, you could say it's 4 to the fourth, but either way, that's going to come out as a 2 and a 2, which is going to come out as a 4. Some of these complicated problems are designed to come out very simply if you do things right. This is not the only way to do it. You could have said everything's a factor of 4. That's 4 cubed. Maybe that's easier. Maybe I should have done it that way. If this is 4 cubed, which 64 is, and another 4 there, hopefully you'd see that's 4 to the fourth. If I take the fourth root of the whole thing, that's just going to give me 4. Maybe I shouldn't have done it with 2's at all. But I got there. I got the right answer. But a quicker way would be seeing that that's 4 to the third, that's 4 to the first. When I combine them together, I'm going to get the fourth root of 4 to the fourth, and it comes out as 4. Okay, so that one was kind of messy, but I think you still get it. Okay, here's one that's even a little bit messier. Okay, different ways to get there, but again, I think this one's going to give us a simple answer. Okay, this is like 6 squared, but the cube root. You've got to understand that 6 to the 2/3 is 6 squared to the 1/3 power. So I hope you see that. There's the 2. There's the 3. Might seem funny because you see 2/3 there, but that's accurate. Okay, this is like 4 squared. Take the cube root of it. Okay, and this is all under, excuse my writing here, it's messy. This is all under 3 squared. I'll take the cube root of that too. Okay, so what does this do for us? How can I simplify this? Well, it's going to be 36. I know that's 2 times 3. So first of all, let's do that. That's going to be a 6 squared is 36, which is really 9 times 4. So I can go 2 squared times 3 squared, right? All under the cube root. Oh, and there's another 4 squared. That's 2 squared twice. 2 squared and 2 squared. I hope you see where I'm getting all this. Okay, 4 squared is 16, which is 2 to the fourth. So there's 4 times 4. There's 4 times 4 because it's squared. So I hope you see where I got that. That's from this one. 2 squared times 3 squared. Well, 6 is 2 times 3, but they're both squared, so it's 2 squared times 3 squared. Now I can divide this. It's all a cube root. Now I can divide this by this. If the root is the same, then this whole thing just cancels this. Okay, cube root of 3 squared, because I could pull that out front. If it makes you feel any more comfortable, I could have done it like this. Cube root of 3 squared, I could have written it as 9. And then this on the bottom was cube root of 3 squared, and leave behind all the rest. That's 2 squared times 2 squared times 2 squared. But these cancel. That's what I just did here. I just did it within the radical here. Okay, so where does that leave us? Okay, well, that's something, that's some object or some variable, some number cubed, because it's this times this times this. So it helps you better to see it like this. Anytime I've got three things multiplied together, you can write them as 4s if you want. I've got 4 times 4 times 4. If I take the cube root of anything cubed, right, that's 4 cubed. Well, it comes out as what? 4. That's my final answer. Okay, so these things are a bit like puzzles. You can get at it a variety of ways, but notice that we had 2x up here down with these number ones. I think this worked out to be 4. The third one also worked out to be 4. There's nothing special about that number, but a lot of times when they give you complicated problems like this that can look intimidating, if you do some canceling, typically things might work out to give you a fairly simple answer. I hope that helps. Our goal is to just have you be familiar with how these things go and how to simplify radicals and how to use the rules of radicals and exponents properly.